Chemical equilibrium is a state in a chemical reaction where the forward and reverse reactions occur at equal rates, resulting in no net change in the concentrations of reactants and products over time. At equilibrium, the concentrations of reactants and products remain constant, although the reactions continue to proceed in both directions. Chemical equilibrium is governed by the equilibrium constant, K, which describes the ratio of the concentrations of products to reactants at equilibrium for a given reaction. To shift reactions towards completion and favor the formation of products, several factors can be manipulated. Changing concentrations. Increasing the concentration of reactants. Le Chatelier principle states that if the concentration of reactants is increased, the equilibrium will shift to the right to consume the excess reactants and form more products. Removing products. Continuously removing products from the reaction mixture, e.g., by precipitation, extraction, or gas removal, can shift the equilibrium towards the formation of more products, as the system tries to replace the removed products by favoring the forward reaction. Altering pressure, for gaseous reactions. Changing volume. For reactions involving gases, changing the volume of the container can affect the pressure of the system. According to Le Chatelier principle, if the volume is decreased, resulting in increased pressure, the equilibrium will shift towards the side with fewer gas molecules to relieve the pressure, favoring the formation of products, and vice versa. Manipulating partial pressures. Changing the partial pressures of reactants and products by adjusting the initial amounts or changing the container volume can influence the direction of the reaction. Adjusting temperature. Endothermic reactions. Increasing the temperature shifts the equilibrium in favor of the endothermic reaction, the reaction that absorbs heat, as it consumes the added heat. Exothermic reactions. Decreasing the temperature favors the exothermic reaction, the reaction that releases heat, as it compensates for the loss of heat by producing more heat. Catalysts. Adding catalysts. Catalysts increase the rate of both the forward and reverse reactions without being consumed in the process. While catalysts do not affect the position of equilibrium, they can accelerate the attainment of equilibrium by speeding up the rates of both reactions, resulting in quicker establishment of equilibrium conditions. By manipulating these factors, it is possible to shift chemical reactions towards completion and optimize the yield of desired products. However, it is essential to consider the specific characteristics of each reaction and the potential consequences of altering reaction conditions.